So we rely cái name platform with Hyperbot solution. So with the next slide, thì we
Good morning, xin chào, Sawadika. My name is Ian and I will continue with basic capital measurement and improvement. So for summary, we will check detail plan for the solution that we will define. Good morning, xin chào, Sawadika. My name is Ian and I will continue with basic capital measurement and improvement. And then so for summary, we will check detail plan for the solution that we will define. Good morning, xin chào, Sawadika. My name is Ian and I will continue with basic capital measurement and improvement. And then so for the check on the app for the solution that we define. Good morning, xin chào, and then so for the check on the app for the solution that we define. Good morning, xin chào, and then so for And after aligning with self-team, which was opportunistically as the place that we got pilot for this project, and we used the webline date on July 2023, and now we can see that our customers can place the order on the publish or opportunistically with stocking for it as the place that we got pilot again this project. And we used the webline date on July 2023, and now we can see that due to adapt time with the rule of the outlook for the sale order with the opportunity happen. The first one again this region and only when the SBFAP which means that our retail has where they can do adapt time gradually affect our down for the sale order. I would actually adapt time happen the just with this platform something already and when we are our SBFAP cost which means that our cost and we have engaged to that time that we affect our forward on which there are actually two small batches. The first batch is the platform and we are not doing and for the batch there are also and we API to the system that will measure the normal batch degree, the first batch and so always got a small batch and we for the batch there are and because the second batch is very minor so that we can our manage so we very measure the batch degree and they also go out and check the August and you see the successful result. And this is the result we want to go live and we the that we can reduce the main overwork of activity for our customers more than 100 hours this month and the result and after the success of how to play the project will start raising people now is the main overwork for the first which was the 100 hours this month and after the campus we are still fine and after make the subject for and then we recognize that for the excellent and is very close in the distance so that is the line without putting our after non-campus and still fine and make the subject show that if they will recognize what we think the college excellent travel to the city is very close of the line without putting so with that, we that's the it's specific by 10% and we can reduce the minimum work for activities and customers the area execute for the and what it's regarding average cost by the annual and cash and we can reduce the minimum work and we also this plan for this objective we identify customers that regarding for and the for this and this is the example we use to when the business happens regarding last technology is of the process and what you do to financial reasons and that regarding for financial this is the past we are very proud to say that not only bring the business back regarding technology and what you do and also for our for our and I mean we are very proud of that and our bringing the business back regarding technology I mean all the success and increase the satisfaction and for SBFAP we can provide 10% for SBFAP, which means that we can have a generous and quick and environmental living of less than 20 years. And in the way I'm talking about it, also reduce the manual work where and we create a manual calendar ultimately 10% for SBFAP, which means that we because now as we often get higher volume comparison, that is we have like higher revenue, right? For traffic, and we create a manual calendar ultimately 10% for you and I, for yet they can have revenue because now as we higher risk, we're ready for the challenge. They're the brand like higher revenue, they get back to us, we have to understand how we are and we can create our ultimately capacity and like for yet they can have revenue because opportunity, we have the first one is brand Southeast Asia, they get back to us, that we're going to understand how we are performing, based on the total output of this now and for the second opportunity, we will apply to a opportunity of the promise to play out to and bring our so that we will aim about the performance based on the total output of this now and for the second opportunity, we will apply to a opportunity of the promise to play out to and bring our
Thank you. So, thank you very much for that. Before we start the Q&A, that's so much. Before we start the Q&A, I was just thinking that we talk about organization. I'm actually thinking about sustainability perspective of that as well, because we already have this good project, and I think that's together with the sustainability agency, how much CO2 we have saved because we take my thought, because I'm very sure that we are actually thinking about sustainability perspective of that, because we already have. Okay, right, so let's take questions from the leaders and audience because it is online. You can just use because online or just raise hand and then go quality. Okay, right, so let's take questions from the leaders and audience. First of all, very good project online. You can just use manufacturing facilities, logistics, raise hand and then go quality. Customer service. It's really good project. And this is very good project. We're actually just trying to accommodate we're seeing cities forecast accuracy is customer service. It's really good the right product and the right disease. And this is very good. You still have double hands on it. And that's kind of only that. I think people centralized the forecast customer is very good. Really get the right product and the right results. And when we're something we want to get the forecast accuracy. And we still have double hands on it.
Actually, we recap the margin to accuracy, because you can see that for accuracy already 26%. However, we also work with the CVG, and we actually see that this is by the that's why we can improve accuracy further. You can see that for accuracy already the accuracy and then so this means that you can see region and just a little bit actually see that this is but by the that's why we can improve by accuracy further. You can see that for accuracy but already the accuracy so that we can so this means that you can see region and just a little bit see that this is but by the
could you have something that you put up on PCA or CP? Have you seen a gradual result?
We always move for the off-pallet drug, which means that, for example, the customer use the drug-free pallet, right? And the customer order like 9 pallet in total. And for the DC one, they have 9 pallet, and for the DC two, they have 4 pallet, which means that we always move for 2, and the off-pallet which means one so which means that we only travel one pallet from the second destination to make sure like all three pallets and in just one way they have to five pallet in order that two they have four pallet which means that our pallet is 1 and the upper pallet is which means one so which means that we only travel one pallet from the second destination to make sure like all three pallets and in just one way they have to five pallet in order that two they have four pallet which means that our pallet is 1 and the upper pallet which means one so which means that we only travel one pallet from the second destination to make sure like all three pallets and in just one way they have to five pallet
After you mentioned the auto station,
Let me have a brief on this. This is firstly, we came with the academic research and also the research research. We started the market, but it's visible of life. Let's have a brief on this. We break the artist. Firstly, we came with the bigger one. I can see that we have some of the research. We started the market. This is price of like visible even like on and over cost. Let's have a brief on this. We think about the idea how about we convert the video waves that provide this is price of like the even like needs that we bring in the work is for how about the like the work and I think that discuss that and we got outside the price of like fully even deliver needs that we bring in
so which means that like we have the state approval and then we bring with our using that this is our we want that to work in that way and then our attitude will based on our brief to build an outlook they will like do some coding in the top platform to be always we have the state approval to do this with our using that it's not the tool in the market but to develop by our pathway and then our attitude will based on our brief to build an outlook they will like do some coding in the top platform to be always we have the state approval to do this with our using that it's not the tool in the market but to develop by our pathway and then our attitude will based on our brief to build an outlook they will like do some coding in the top platform to be always we have the state approval to do this with our using that it's not the tool in the market but to develop by our pathway and then our attitude will based on they will like do some coding in the top platform to be always we have the state approval to do this with our
Everybody, coming from Sydney today, just fantastic presentations and the focus on customer service and all of the systems integration, very complex as well. So congratulations. I have two quick questions today. One was just fantastic presentation there was, and I suppose in the duration of the project, there was a period of time when the system needed to be built. I'm wondering what the containment to quick question in the short term while the system was being built. Did the team adjust any process in the interim to the system try to be built on the improvement in the customer service contained the long term countermeasure was being built? And the second question was, did the team reach out to any other regulatory supply chain assistance how they were building on the improvement situations behind the long-term countermeasure was being built? And the second question was, did the team reach out to any other regulatory supply chain assistance how they were building on the improvement situations behind the long-term countermeasure was being built? And the second question was, did the team reach out to any other regulatory supply chain assistance how they were building
why use less time also understanding.
Step 10 for step 10 for final step. Challenge for the
Yeah, so the question is, in the problem solving, there are other untoward supply chains managing similar situations. Did the team reach out in the early stages of, yeah, so the question is, understanding the problem and looking for a solution, did the team reach out to any other untoward operations around how situations? Did the team reach out in the early stages?
So, regarding to the second
yeah, so the question is,
understanding
the problem and looking for a solution. Did the team reach out to any other
because more like we also study the
around how
operations
situations? Did the team reach out in the early stages?
So, that's the second
Yeah, so the question is,
similar operation model customer service. We also just study based on the available production. So that's what so we see that we can share we also one thing that we learn by study is apply available production. This is what we present in our project. So we can detect it. So we see estimate production and share all the process. Increase our further one thing that other by study is that we can apply the optimal production. This is apply for present in our project. So we can discuss things when in estimate production. We do like so we can verify the ability from this applied to be friends that we can discuss things when in estimate production. We do
So the first one was on page 11, how we what did you do to this thing? How did you manage? I think how to say that. So the first one was on page 11, how we what did you do to this thing? How did you manage? I think how to say that. So the first one was on page 11, how we what did you do to this thing? How did you manage? I think how to say that.
So
Yeah, you can see.
Okay, so while entering, we start to roll out this project like separation advisory, which means that when we pilot the project for SNC, all the other separate still operate as original model because we work on the integration. Okay, so while entering, we start to roll out this project like SNC and for which means that has not pilot this project, it still has anything to work on to all the yes, operate and so when we design the other project, we still expand that integration to our like it doesn't affect any operation, which means that has not pilot this project, it still has anything to work on to all the yes, operate and so when we design the other project, we still expand that integration to our like it doesn't affect any operation, which means that has not pilot this project, it still has anything to work on to all the
Our second presenter for the day is from SBFAP for their presentation. John, Abby. Alright, guys. Our second presenter for the day is from SBFAP
How can we get as can I and easy can wait for the 45 everything like there and how can we select answer is oh can I and easy can wait for the have the file everything like there work but I can select answer is I can even how to work in clean out the we have the file after we have one after excellent without the CT we can now perform over ourselves without behind our support we can without the CT we can now perform over ourselves without behind our support we can
we also provide five touch point for inhalation. And last step priority, we prioritize treatment on product side as before line. We also consider customer demand for five touch point for inhalation. And last step priority, we prioritize after product side as before line. One choice provider cycle because for five touch point for inhalation.
Is the by into in this project, there are four main departments: production, engineers, QMS, and SET2. Group 1. In each activity, all the mentioned points will collaborate and work together. In this project, there are four main departments: production, engineers, QMS, and SET2. Group 1. In each activity, all the mentioned points will collaborate and work together. In this project, there are four main departments: production, engineers, QMS, and SET2. For identify the mission, we extensively report the endpoint for the sequencing of answers. We demonstrate the achieve that goal by continuously for identifying with the highest layer, the endpoint for the sequencing of answers. We demonstrate the achieve that goal by continuously
Principal element of version of parameter and temperature. These adjectives are related to functional quality. Principal element of version of parameter. Principal resulting actions the composite for parameter will have 5% temperature, 5% adjective details except parameter measure goals except parameter after that we will for change and last adjust parameter for except parameter memory measure goals in the after that the difficulty of creating process adjust parameter from after that, the money of activity after that, the 20 most challenging of activity is we set of lighter workshop for the training most challenging because like one workshop the training is for safety because like one however, we have set handle it safely, we can compute after that after we have handle it safely, we can compute
in some judging mechanical parts of it, it can lead to various Allowability has developed but this is divided in some easy to understand sections. One of the and lead to various adjusting the big part is easier than adjusting the part because the moving part need a little bit between fast line and easy to understand section. One
Whenever a task moves to another line,
adjusting
there
the
usually
big part
is adjusted by change
and
and
adjusting the part because the moving part need a little bit between fast line and easy to understand section.
we combine touching and whenever a task moves to another line,
Adjusting
there
the
usually
big part
is adjust
and
and
adjusting the part because the moving part
and we have that whenever a task moves to another line, we combine touching and whenever a task moves to another line, there usually is adjust and we have that whenever
of the master which produce is a product and larger than of the license. As a result, what of product of fraud or equivalent of the license of the master when for citizen which product is or indicate that larger than of the we need to indicate as a result. What is process of fraud or equivalent of the license check and another our when we have therefore taken to assign that capital of money for so the only one is process and of participation for check and another
finally, for every activity,
we have therefore taken to assign that capital of money for so
we
the
have
only one
one
is
set
process
of
and of
check capturing evidence. Finally, for every activity, so
we have therefore
first we check quality of the graph, quality of having data set of finally, for every activity, so
we have the line by yes, 1.95 line in 1.5%, 1 liter side and 0 and 5 side. Like we have the 5 yes, 1.50 side, line in 1.5%. So we can do alternative line and all same side.
so if we solve, we can like we have the side x is the
so we can do alternative line and all same
not different. So if we solve, the thing we have the side is our like can show how we can find the not different. First thing we can update this align to get something by how we can find it. We can we can increase of the young man for the additional we don't need to pay for half stop. We can inform transport with a come on one transport we transport as to be see check and delivery and we can inform transport with a come on one thing we will need to be by because we other sale to be see check and delivery
we have a center line, PHP admin, and check what staff activity and activity.
Good point. We follow with
We have a center line, PHP admin, and check what staff activity and activity.
Good point. Better we know
willing to support without the time willing to support without the
Presentation. Now I want to talk thank you. So we agree that the Holy Spirit. Thank you. So let's take questions from our presentation. Now I want to talk thank you. So we agree that the Holy Spirit. Thank you. So let's take questions from our presentation. Now I want
My question is you mentioned
thank you. So we agree
my question is quick question. You my question is quick I want to see very strong active development from and you qualify so what I want to very strong active development from and you qualify study in order for you to grow and so what I want to very strong active development from
I really like this. And I like your analogy of the tree. It takes time to grow people. So I feel like you understand that. It's growing across the region. A question, a little bit before we consider, I really like this. Just you know, and I like your, did it all by yourself. How do you take your time to grow people? So I feel like you understand that. How do you ensure growing across the region? A question, a little bit before we consider, I really like this. Just you know, and I like your, did it all by yourself. How do you take your time to grow people?
We have a
I feel like you
policy,
how do you ensure growing across the region? A question, a little bit before we consider, I really like this. Just you know, and I like your, did it all by yourself. How do you take your time to grow people?
we have a
I feel like you
policy,
how do you ensure growing across the region? A question, a little bit before we consider, I really like this. Just you know, and I like your, did it all by yourself. How do you take your time to grow people?
we have a policy, เช่นออกเช่นเวลาเกิดขีดออกบอทเทิลมีออกคอนติเนียลแท็กเอาอันนั้นคือฟีวอลลุ่มครับที่อัพเตอร์ปีบอทเทิลมีเป็นขาครับเช่นออกเช่นเวลาเกิดขีดออกบอทเทิลของคอนติเนียลแท็กเอาอันนั้นคือเป็นปีเป็นฟีวอลลุ่มครับที่อัพเตอร์ปีแล้วต้องมีเป็นตลาดก่อนเช่นออกบอทเทิลของคอนติเนียลแท็กเอาอันนั้นคือเป็นปีเป็นฟีวอลลุ่มครับอัพเตอร์ปีแล้วต้องมีเป็นตลาดก่อน
You still change the way you because your landscape are more factors those are number size of the line. You still change the way because your landscape are more factors
very, very simple question. The benefits had the original of a stock build. I'm just wondering, was that captured in the savings for the project? And second question, was there any capital spent in the project? Benefits had the original of a stock build. I'm just wondering, was that captured in the savings for the project? And second question, was there any capital spent in the project? Benefits had the original of a stock. The first, just wondering, the first question was around the stock build, and if you go through the benefits and capital slide, it talks about the receipts don't need to say build. The first, just wondering, the first question is that captured in the 194,000 USD. If you go through the benefits, I'm just checking the team have collated the full benefits. It talks about the receipts don't need to say build. The first, just wondering, the first question is that captured in the 194,000 USD. If you go through the benefits, I'm just checking the team have collated the full benefits. It talks about the receipts
Do you know how value your volume?
the first question is that captured in the 194,000 USD. If you go through the benefits, I'm just checking the team have collated the full benefits. It talks about the receipts
Do you know how
the first question is that captured in the 194,000 USD. If you go through the benefits, I'm just checking the team have collated the full benefits. It talks about the receipts
Do you know how
the first question
Any other questions from the audience?
Yeah, I understand that you are going to request the line. So you have a different set of check marks. The check mark, I mean the already there. So now you just do. Yeah, I understand that you are going to request the line. So you can save and different set of check marks. So the cost of the whole check mark, I mean the already there. So now you just do. Yeah, I understand that you are going to request the line. So you can save and different set of check marks. So again, the cost of the check mark, I mean the can do yourself. So that you can save the cost of that. So yeah, I understand that yes, you can access so you can save and different set of check. So again, the cost of the check mark, I mean the can do yourself. So that you can save the cost of that. So yeah, I understand that yes, you can access so you can save and different set of check. So again, the cost of the check mark, I mean the can do yourself. So that you can save the cost of that. So yeah, I understand that yes, you can access so you can save and different set of check. So again, the cost of the check mark, I mean the can do yourself. So that you can
So we are taking outside 10 minutes. Right, so I think we are going to go for a little break. Okay, 15 minutes. We give so we are taking outside 10 minutes. So 15 minutes from now, we are going to start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, so see you again in 35 okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by right. So I think we are going to okay, 15 minutes. We give so we are taking place outside. So further from now, we will start again by
No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to No, I still I think the team was to
Typical judge.
Typical judge.
Yeah, but we got it through Catholic. Yeah, it's great. Yeah, yeah. There's no favoritism.
Storm Suntory.
Yeah, but we got it through Catholic. There's no favoritism. It's great. Yeah, yeah. There's no favoritism.
Storm Suntory.
Yeah, but we got it through Catholic. There's no favoritism. It's great. Yeah, yeah. There's no favoritism.
Storm Suntory.
Yeah, but we got it through Catholic. There's no favoritism. It's great. Yeah, yeah. There's no favoritism.
Storm Suntory. Storm Suntory.
So let's continue with the number 8.
Storm Suntory.
I would Australia from South Australia with a big stage. So let's continue with the number 8. Alright, the American has a great takeover. I would Australia from South Australia with a big stage. So let's continue with the number 8. Alright.
You guys hear us okay? Camera's not on. Oh no, it's on. Now we're good. Okay. Any problems on your end here? You guys hear us okay? Camera's not on. Good to go? Yeah. Oh no, it's on. Now we're good. Okay. Any problems on your end here?
Tenakoto katoa. Xin chào. Sawadika. Ni hao. Malo lele and greetings to you all.
Oh no, it's on.
Welcome to our Suntory Oceania first Kaizen
Any problems on your end here?
Tenakoto katoa. My name is Sulia and I am a Tongan. I am from our inwards goods team. I've been with this company for 14 years. 10 years on our production line and 4 years with our inwards goods team. It is an honor and a privilege to be standing before you today, alongside with my co-presenter, to share our Kaizen's journey to success. 14 years, 10 years on our production line.
Graduate.
It is an honor and a privilege to be standing before you today. Wow. Alongside with this is our achievement from our Kaizen's journey to success. We started our journey with implementing the SBFAP 10 Steps Kaizen as our guideline. It is an honor and a privilege to be standing before you today. Wow. Alongside with this is our achievement. 10 Steps Kaizen team is our 10,000. It is an honor and a privilege to be standing before you today. Wow. Alongside this is our achievement. Ladies and gentlemen, sit back, relax, and we will take you back 10 Steps Kaizen team of our 10,000 to success. This is our achievement 62. We are based in Ladies and gentlemen, Auckland, New Zealand. Sit back. We have 8 production and we will take you back 10 Steps Kaizen. We produce a quarter of a billion liters each year. with 262. We are based in Auckland, New Zealand, a range of delicious beverages, and we will take you back to the quarter of a billion with our V brand. We are with 262. We are based in Auckland, New Zealand, a range of delicious beverages, and we will take you back to the quarter of a billion V brand. We are with 262 mission. We are based in Auckland, New Zealand, a range of delicious beverages, and we will take you back to the we are with 262 mission. We are based in Auckland, New Zealand, a range of delicious beverages, and we will take you back to we are with 200. Was with our V brand and Celsius joining. With the demand, Suntory Oceania is projected to produce greater volume better than before. This means higher OEE with maintaining our best quality products for our customers is desperately needed for success. With the demand, Suntory Oceania is projected to produce illustrate greater what was happening before our Kaizen started. This with increasing demand, unfortunately, more mistakes is our destiny is resulting in more write-off and reduced OEE. We focus more on reducing customers' complaints and quality issues. With increasing demand, to fully understand our current situation, it is important to understand our role in the business. At Inwoods Goods, we manage 305 different raw materials. These arrive on site and are stored in one of our 6 different storage locations. In the batching team, we measure, mix, and prepare these raw materials to create one of our 113 syrups, which creates 276 of our delicious storage locations. This is our weary site. Genjutsu, where we saw the actual condition of our current state. From there, we could pinpoint the minimal opportunities where the machines breaks down, the moderate opportunities, product design, Genjutsu, issues, where we saw the actual condition of our current state. Picking the incorrect from there, we could pinpoint ingredients, the minimal opportunities, stock control, where the machines breaks down, and delay in the moderate opportunities, Product design genjutsu, where we store the actual condition of our current state. From there, we could pinpoint the minimal raw materials where we where the machines break down. The moderate opportunities. Product design genjutsu, where we store the actual condition of our current state. From there, we could pinpoint the minimal raw materials where we where the machines break down. The moderate opportunities. Product design genjutsu, where we store the actual condition of our current state. From there, we could pinpoint the minimal raw materials where we where the machines break down. The moderate opportunities. Product design genjutsu, where we store the actual condition of our current state. From there, we could pinpoint the minimal raw materials where we where the machines break down. From here, product design genjutsu, where we store the actual condition of our current state. From there, we could pinpoint the minimal raw materials where we where the machines break down. From here, product design genjutsu, where we
see, the ingredients have not dissolved and blocked the filter. This causes problems and creates waste. We compared our process to other sites across Suntory and reviewed supplier recommendations. Our process was not suitable to batch Lucozade Orange with temperature and shear not being up to standard and blocked the filter. This ultimately, all three of our hypotheses proved to be true, allowing us to continue with our Kaizen. There was a gap in raw material management, tank capacity and chase water was not considered, and finally, dextrose did not dissolve completely and block the filter. Step 5, root cause analysis. The first problem was the capability gap in raw material management. Through a YY analysis, we determined two different root causes. Daily management was not effective because of how we handle raw materials, and also the process between batching and inwards goods was not set up for success. The first problem was the capability gap in raw material. The second problem was the overdilution of batches. We started with two problem statements. Syrup was not homogeneous, and chase water was not considered in our specification. Also, through our RCA, we determined that minimum order quantity did not align with batching capabilities, and the set points for transfers were not optimal. This analysis was for the blockage issue with lucozade orange. We identified two key root causes. The formulation did not consider dextrose requirements, the temperature and shear, and the current mixer capabilities was not fit for purpose. All three of our RCAs were followed by going back to Gemba to ensure that these were the root causes. Step 6, countermeasure and improvement. Here, we have a high-level timeline of how our 10-step Kaizen tracked over the past 12 months. Initially, we tackled the raw material aspect, solidifying our staging for the root causes. We also began to dive into lucozade orange before moving forward and standardizing other improvements, such as minimum order quantity with plant Kaizen tracked over the past 12 months. We really improved the daily the raw material aspect, solidifying our staging for the root causes. We also began to dive into lucozade orange before moving forward and standardizing other improvements, such as minimum order quantity with plant Kaizen tracked over the past 12 months. We really improved the daily the raw material aspect, solidifying our staging for the root causes. We also began to dive into lucozade orange before moving forward and standardizing other improvements, such as minimum order quantity with plant Kaizen tracked over the past 12 months. We really improved the daily the raw material aspect, solidifying our staging for the root causes. We also began to dive into lucozade orange before moving forward and standardizing other improvements, such as minimum order quantity. A culmination of these two actions allowed for lucozade orange to be batched in specification and one of the most effective across. Chase water set point optimization, a project that was worked on with SMEA and engineering to ensure minimal water contamination based off piping volume. For one of our canning lines, we have had great success with the volume reduced by over 60% without compromising yield. We used SMEA to expand our capability and knowledge to carry out this action. Through these actions, we have exceeded our goals with an 86% reduction in raw material and batching write-off. This equates to approximately $650,000 USD saved. In terms of batching and inwards goods delay, we achieved 56% reduction and approximate $100,000 USD saving. Our third goal being relationships and morale, which is not quantifiable, We've also achieved this shown in our daily meetings and continuous alignment. Step 7, effectiveness evaluation. To sum up, a 750,000 benefits for Suntory. One Suntory. We collaborated and worked with various functions and sites within Suntory. 2, cross-functional growth. Relationships have been built to bring us all together. 3, engagement and Kaizen capability. We use various Kaizen tools and develop Gemba activities. And 4, creating a safer work environment and well-being. This has been achieved in both functions.
Step 8, standardization. To ensure that our Kaizen activities are maintained, we implemented the 4 M's: man, methods, machine, and material. We upskilled our teams, we updated our documentation, we improved in our batch management, improved on our raw material control. We implemented the team assurance to ensure our teams are communicating clearly and performing to a high standard. We updated standardized our batching instructions with our R&D team. The staging process was introduced and formalized across both teams. Step 9, review our process. We contributed to all the Monosokori mission and principle statements, along with some great wins. We completed our Kaizen to improve delivery and quality, broke down the barriers between teams and increased morale, cross-functional Gemba with both teams, including R&D and planning, strong demonstration of our Gemba power. Step 10, challenges for the future. Keep implementing the 3 Gents approach, maintain positive relationship, further reduction in downtime and write-offs. For horizontal deployment, we implemented the process into our NPD and shared knowledge with other functions. We are proud to be the first Suntory Oceania Kaizen, and I am sure we will be back with more improvements for the future. Ladies and gentlemen, this is where Inwards and Batching are signing off. Special thank you to all our SBS families around the world. We wish you all the best for the rest of the year. One final message from your families back here in New Zealand. If we think big, we dream big, our result will be big. Believe us, we did it, and so can you. Maloha Pito, thank you, and haere.
Well done, well done.
Thank you, Mr. Elwood and Mr. Sonia. So I actually saw 10,000 kilometers, right? So you should have actually convinced Ian to fly here. All right. So let's take some questions. We have anyone online. If we can just take that question first. Lenny. Right. If not, let's take some questions from the judges.
So, right, Akira speaking. I'm in charge of the engineering and planning things. Anyway, thank you so much for a great presentation. Actually, I've been to the Fruit Board Willis site several times a year, and last year, this year. So I understand the line situation, design things. It's not work for us, but the design situation, your presentation was superb, so impressive. And before my question, I want to have some comments. So storyline is very great, and also you refer to the other business, SDVD or SMEA or that kind of benchmarking is great. So yeah. Anyways, I'm very impressed with your presentation. Thank you so much. And my question is, after you've done this kind of great activities, but you still have some improvement points. So regarding the expired raw material or probably 35% reduction things, but you still have a 65% something. So what's your next target or next activity for improvement this point in the future?
Sorry, was that what are the next steps moving forward? Sorry, I just wanted to confirm.
Yes, improve further.
I think moving forward, it's ensuring that we're standardizing and maintaining the actions we've done. A lot of the flaws, I guess, while we're not reaching 100% in most things, is small faults and slips in the maintaining aspect. So I think with the actions taken in terms of our goals and whatnot are correct. It's just a matter of maintaining it, ensuring that we're following it up through leader standard work and daily operational reviews that we do through team assurance. So it's just keeping our teams accountable, making sure that communication lines are clear. But I think, it's just moving forward, working together, and then ultimately, in the longer term, we've got our master plan that'll change capital and infrastructure that should contribute to a hopeful 100% reduction in everything. But I hope that answers your question.
Yeah, thank you so much. I'm working with Ian and Adrian's very further as a discharge. So I'm with you. Thank you so much.
Hi everyone. Alan here. Listen, thank you for an excellent presentation. It was really exciting to go through that. I feel I've experienced a lot of it with you over the last 2 years. But fantastic work. A couple of questions. You mentioned the first time ride, and also how the batching impacted the OEE of the facility. Where are we today in terms of first time ride, and have we seen any improvement in OEE due to your activities?
We've definitely seen improvements in both of those aspects. I don't have the numbers off the top of my head, but definitely in terms of OEE, it's batching has been and can be a bit of a bottleneck. So it's not holding up the lines, ensuring that we're delivering in full on time for each of the production lines. And then in terms of first time right, that comes more from, I guess, the batching and inwards goods team, ensuring that they're carrying out their tasks correctly, so that when the production lines do need their syrups or batches, I'm not sure what you guys call it, sorry, that they are prepared in spec and on time. So, yeah, I think.
Good. Okay, very good work. Thank you.
Any other questions? Anyone from online? The question, you can just unmute and ask. From audience have been quite silent. Quiet today. Focusing. No? All right. I think if there's no other questions, thank you very much.
Thank you.
Thank you.
Right, thanks. All right, now we move to our board presenters from Vietnam, Dong Island. Mr. Long and Mr. Kung, reducing syrup loss to decompression for PET cool fill process. Over to you guys.
Morning, everyone. My name is Good. And my name is Tom. I'm from Dong Island SBFAP, and we are really honored today to stand here to tell you about our journey is continuous improvement. Our Kaizen topic is reducing syrup loss through decompression for PET cool fill process. And our group consists of the members from engineering and quality control department. Let's take a brief about Dongnan plants. Right now we have 8 production lines, and we are honest and really proud because we can deliver more than the 30 SKUs. And our journey will follow the 10 steps, and each of them contributes our growth and the success. During our journeys and process, we proceed to the zero loss through the continuous technology for innovation, developing on-site capability and working people. This embodies the century monoculture value and ways. Moreover, we follow to achieve the Dongnan Plan's moving battle in transformative engineering, end-to-end supply chain, and especially the data capture. In 2024, Dongnan Plans want to enhance our productivity, so we make the productivity target to saving $1.3 billion. So as you can see, there was a lot of the project that in the top 2 category. So we focus on improve the use saving, especially the constant use. To understand more about the current situation, let's move to the step 2. In Dongnan Plans, we have the 3 CSD process line with the different OEM, CDL, KHS, and Pro. So let's take a look at the concentrate use of them. In the CDL line, you can see there is improvement yearly, but it just have the huge gap with the other line. So we should focus on this. And we have the question, what's the difference between the CDL line and the other? So to answer this question, let's take a brief in the historical of the timeline of CDL lines. As original, this line can run both CFD and hot fill product. But after that, it switched to the CFD, just run CFD product. After that, switch to Aquafina, and right now, this is the first ever spring line of SBFAP because we decided to run both CFD and Aquafina. Deeper, just let's make the comparison between the fueling technology in CDL and the other. You can see CDL controls mechanically. This means that it's an old version technology by using the scan and level and roller, something like that to control. And the other line, for example, the ProNet or KXS is used the control electrically by using the flow meter. This means that the CDL line less precision. So understand this disadvantage. We do a lot of the project, yes, a lot of action to improve the stress use of this line. And as you can see, it's improved year by year, but this just have a huge gap with the other. So, and you know, for 12 years, we not work alone. For 12 years, there was 4 times we worked closely with OEM to solve this problem. And on of the 4 times, we received the same answer from OEM that this problem is just normal with the old version technology fueler, and again that we should change to the new fueler. But with the Yatamina having experience, we continue to find a way to resolve this problem. So we set in 3 main targets for this line. First of all, we want to improve the concentrate skill for the CDL line. Secondly, we want to exceed the AOP target of 99.2% by reaching 99.5% onwards. And last but not least, we want to contribute to make the productivity and reduce saving reach $119,000. Coming to step 4,
for a holistic approach, we plan to conduct a thorough review of the entire process to identify where are the sources that is causing absolute loss, and that would lead to our constitution yield to be low. So we have been able to identify that there are four main areas that is making absolute loss and cause the constitution yield to be low. Then there are absolute mixers and fillers and mixers and then packaging areas. And among all these four groups, not surprisingly, the fillers takes into account the largest amount of absolute loss. And this is mostly coming from the filling process. And further gate-by measurement show that the amount of absolute loss is coming through the combustion pipeline, which is a part of our filling process. And the numbers of absolute loss through this pipeline is at a staggering numbers of 3 liters per minute. So what is decompressions? Let's head on to the next slide, where I will explain to you the basics of CSD filling principles. So because our products is CSD, right? So it is a gas-contained products. So in order to the CO2 to be dissolved into the products, we have to pressurize the bottles with gas, right? So therefore, at the end of filling cycles, we need to decompress that pressures. We need to decompress that gas out of the bottles to avoid foaming. So this is our CDM model fillers that is controlled mechanically by the cam and levers, as you can see here in the videos. So let's move on, where I will explain to you the five most important steps that affects the most to our filling process, and they are pressurizations, fillings, first decompressions, stabilizations, and second decompressions. So for the first is the pressurizations. At this point, the can would move the gas level up, and then the pressures from the filling bowl is put into the bottles. For the fillings, when the pressure is filled into bottles and the isomeric states in which the products would then flow into bottles, and some of the gas inside the bottles will then return back to the filling bowls through the pipeline. And then from the first decompressions, the can moves the gas level down, and the residual gas is then released through this pipeline. And then come the stabilizations, where the can moves the gas level up to its closing positions, and it will close the pipe for gas release, and then the gas would accumulate here at the bottlenecks. And similar with the first one, the second time decompressions, the can moves the gas level down once again, and this time all remaining gas will be released through the pipe. So regarding the decompression piping, after the CO2 is snipped out from the bottles, it will travel back to the rotary manifolds and then access at about number 6. And the problem that we are facing here is that there is too much syrup that is coming with the gas, and that is causing our syrup to be leak. So now we have clearly identified our problem. Let's move on to step 5, where we approach our problem by FOIM analysis and pipewise. So for FOIM analysis, regarding mains and materials, we have been able to eliminate these factors. We have checked carefully that these are not affecting our problems. However, at the machine and method, there are some factors that we need further verifications. For the machines, it could be the CO2 inlet and outlet, whether if there is any leakage of the CO2 inlet and outlet. And the third one is that the flow rate of the gas for the decompressions, whether the flow rate is too high, that is making the syrup coming out with the gas also. For the method, it would be the parameters of the filling bowls and the timing of each filling phases that need for the verifications. So let's move on with our first one, is the parameters of the filling bowls. So as you can see here in the chart, at the given temperatures and pressures, we can identify the gas volume accordingly. So we can conclude that the gas volume inside the bottles is affected by both the temperatures and the pressures. And if one of these two conditions are not setting correctly, it would lead to foaming and would lead to decompression loss. So in order to verify this, we use a CO2 calculators and we input with our current conditions. We input it with our current filling conditions, and we have been able to calculate our gas volume, our CO2 solubility in our products, and we then cross-check it with our product criteria, and we find that the results in accordance to our product criteria. So we now can confirm that the parameter setting is correct. And let's move on to the next one, is the timing of filling phases. And in this case, it would be the stabilization time and the decompression time. So for the stabilization time, we cross-check our settings with the serial manuals, and we find that the actual setting is in accordance to the serial manuals. And for the Gemba shows that there is no abnormalities during the stabilizations. For the decompression phase, we do the same. We cross-check our current setting with the OEM manuals, and we find that the actual setting is correct. However, at this time, during Gemba, we found that there's a little bit of foaming at the end of the decompressions, as you can see here. At this point, there's no foaming, right? But at this point, there's a little bit of foaming right here. So it would cause the sirup to exit through the decompression pipeline. So that is our notebook number one. So as I have previously mentioned, our filters is controlled by the cam mechanisms. So we have to check the electrical control on the cams and the pneumatic cylinders, and we find that they are all in good conditions. But however, for the positions of the cam, we find that our decompression cam is mounted too close to the stabilization cams. That would lead to the decompression duration to be too short. So that is our notebook number one. So for machine, we then check the leakage of the CO2 inlet. We carefully check every mechanical parts, and we find that they are all in good conditions. So we can now verify that the CO2 inlet have no leakage. Similarly to the CO2 outlet, we check every mechanical parts that may cause leaking and find that they are in good conditions. So lastly is the flow rate, as I mentioned before. And for CDM, it does not have the specifications for flow rate in the manuals. And as you can see here, if the cross sections of the pipeline is large, it would lead to the flow rate to be large too. So for our filling valves, the gas would flow to 2 points. The first one is the mobile disc. So we raise the questions that could these diameters of the mobile disc be made smaller or not? That is notebook number 2. And the second point that the gas would run through is located right here. It is run through the orifice. And similarly, we also raise questions that could this orifice be designed smaller or not? That's our notebook number 3. So in summary, we have a total of 3 notebooks. For the first one is that the decompression can is mounted too close. So we come up with countermeasures to move the can further to keep the decompression phase more time, more duration. For the diameters of the mobile disc, this mobile disc is manufactured originally by Seals and is very expensive and hardly to change. So it is not optimized when we approach these directions. For the orifice, because the orifice is a small one, right? We can self-make with a new one with smaller diameters. It is easier. So for notebook number 1, we would move the decompression can backwards 40 centimeters. That would allow for more time for decompressions. So after fixing notebook number 1, we find that the amount of slip loss has reduced from 3 liters per minute to only 2.1 liters per minute. But when benchmarking with the other side, we find that there's still laggage and there's still room for improvements. So let's move on to notebook number 3. And it's that can the orifice be made smaller or not? So This part is a little bit tricky since it involves in a little bit of math and physics, so please bear with me. So in order to calculate the new orifice design, we need first to calculate the design flow rate. So here we have this one, if it has spray, right, is the total gas volume that we need to decompress. We then measure this hairspray volume and then divide it by compression time to calculate our design flow rate. After we have the design flow rate, we then compare it to our actual flow rate. So the original designs of our orifice is 4.2 liters, would result in a flow rate of 1600 milliliters per second, while our design flow rate is only 245. So we conclude that the current orifice diameters result in too large flow rate. So we then would calculate the new orifice diameters for our filler valves, and for a holistic approach, we would calculate it for our different SKUs of different volumes and ratios, and we have decided to choose the new diameters of orifice to be 1.5 meters. So we have modified our original ones of the inner diameters is 4.2 to the new one with inner diameters of 1.5. And the results after we modify this orifice, we have been able to reduce 95.7% the amount of slip loss. Previously, it was 3 liters per minute, but after the Kaizen, it was only 0.13 liters per minute. As you can see here, previously, the amount of slip loss is leaking and it's streamlined, right? But this one is only dripping. So to further back up for our Kaizen, we have measured our concentrate yield, and we have started to apply this Kaizen from May, in the beginning of May, and we have found that our concentrate yield increased rapidly from May onwards. And we have been able to save 3 million in Vietnam dollars, which is equivalent to around 120K in dollars. So when we modify with skin orifice, we have identified that there are some risks because during filling cycles, this orifice only allows gas to run through, but during CIP, part of the CIP flow would run through this orifice. So by modifying it, we would affect our CIP qualities. So we need to come up with our action plan to take sensory samples and sensory and micro samples after each CIP cycles. And we have been able to clarify that by making these modifications, we do not affect our CIP quality. So for step number 9, in the process, for tangible effects, we were able to raise our concentrate yield and make savings. For intangible effects, we have by applying continuous technological innovations by challenging the original OEM designs, by applying gamblers through builder gamma cultures, evaluating problems based on facts and figures, and practicing our people. So for step number 10, that would be challenging futures. We would look forward to improve the same problem of single blocks through regressions with the growth line. So for the growth line, it has similar design. It also has the decompression pipeline, and it also has this orifice with original design of 3.0 millimeters. And similarly to previously, similarly to the single line, it also has the decompression pipeline. As you can see here, the single blocks is also lit through and is streamlined, right? So we would aim to make Kaizen on our close line. So from this streamline leakage to only dripping. So by applying the same equations and calculations, we have found that the ideal orifice would be 2.9 millimeters, but the original design is already 0.3. So for this case, it's much harder since we would need solar reviews and modifications of our filling parameters to reach the optimal flow rate. That's all. Thank you for the listening.
Very impressive the presentation where we actually challenging the design of our OEMs and improving the design. So we hope to see other meetings, working on other models as well. Yeah. So I'd like to open this opportunity for judges. Yes.
Thanks for sharing. It's good project, right? Can you change to the setup you lost that you have the graph on the bottom left? Which slide? This one? No. 46. Okay. Now, with this one, I have a question that from March to July is keep improve on the concentrating, right? Yeah. This one for my line, the project. Yes, right. For the critical line. When did you change the
But before that, let's spend some time for introduction. So this is me. I'm 24 years old, and my hobbies is cooking, reading, and listening to music. So basically 2 years ago, before joining SBFAP, and this one fact about me. One fun fact about me is that I gained almost 15 kilograms in just 1 year joining SBFAP. So look at me now. You can tell how much confidence I have.
And my name is one fun fact about me. I used to be a bodybuilder before I joined SBFAP. My hobby is journaling and meditation.
Okay, so this is the rest of my team, 9 people from all departments. In the first step, so this SBFAP stands for the core value and policy of SBFAP, and we with SMV, our project helps to deliver the mission, creating safe, reliable, and high quality products by 3 principles: continuous technological innovation, develop on-site game bar capabilities, and crafting people. So by using the game bar power and energy management, this project based on 3 pillars: production, quality assurance, and utility to deliver the operational excellence in terms of quality, cost, and environment. So to break down the operational supply chain must-win battle to help complain, this project will help to deliver the KPI, the FMC, and productivity, which is very challenging. So this first chart shows the energy distribution at help complain in first 3 months of 2024. So we can see that electricity is the biggest part, account for more than 60% of the total energy consumption. So this should be the priority for our sustainability KPI. And in the next chart, this shows the electricity consumption distribution for area and products. So we have the aircraft finance, CSD, and hot fuel. And from that, you can see the blowing process currently consumes the most electricity in our plant. However, only this year, we successfully lead and shift several Kaizen projects aiming to reduce the blowing pressure, which contribute up to 15% of electricity consumption on this point. So therefore, there's not much opportunity for saving here. And so now let's look back. We see that the filling process of cold fuel currently ranks second in terms of electricity consumption. So therefore, this can become our next priority. So now focus on the cold fuel, on the filling process of cold fuel only. We see that the chiller currently consumes most of the electricity, around 60% of the pipes. So what is the main role of chiller? In general, the chiller helps to maintain syrup at very low temperature, around 13 degrees C during mixing and filling process. And then when we compare that number to other plants, we see a very big opportunity for saving. And this is the data that I mentioned earlier. So we benchmark the CC filling temperature between 5 beverage plants in Vietnam and also 2 plants in Thailand, which is Sarangui and Rayong plants. And from that, we see the current best practice for 60 filling temperature is around 17 degrees C in Magnum plant in northern part of Vietnam. So why Hóc Môn only 13 degrees C? And how to reach that number? We have the fact that whenever we try to increase filling temperature, the following issue will happen. And with that question, we have a short meeting with 3 OEM from KHS, Pronex, and also Shidero. And from their suggestion, there are 2 main approaches. The first one is to invest in new technology. We have the bubble cracker equipment with the total investment around $50,000. However, this technology is already trial in SBFAP last year and the performance unstable. So therefore, we will not go with this one. And the second option is to modify the filling valve and the filler mold designs. And it's like buying a whole new filler. So the cost is much more expensive. So if we go with this one, we can possibly reach to 23 degrees C in filling temperature. It's the world best practice. However, we have the long waiting time and the saving may not justify the investment. But fortunately, we have another option, which is to optimize the filling temperature based on fine-tuning filling conditions. And if we go with this one, we have to go through a trial and error process because there is no formula or calculation to support this. However, this idea comes with no investment, using only internal resources. And surprisingly, that all 3 OEM confirm that this is the most practical solution. So therefore, we decided to go with this one for our Kaizen. And for the objective setting,
we compare between the low gas balloon products and also high gas balloon. And in terms of foaming issue, it's obvious that the high gas balloon products, we have higher risk of foaming. And additionally, in terms of production volume, the low gas also double the high gas. So therefore, we choose the low gas for our priority first.
Under the institution, we set the determined target for this project. In this, the fuel temperature from 15 to 18 degrees C. Higher than the current benefit for CD fuel temperature. We decided that it can contribute due to the better performance in CO2 detection. The data is micro-24. After that, we will pick and seek for the best config using the same principle. The data is micro-24, and we will develop for long run due to loading of funding. To achieve the target, we need to detect the operation process of the mixer fuel system. First, water EDF using CO2 and water pistol inside the air tank. It is with syrup and go to heat exchanger. After that, with CO2 and the heat syrup is pumped into the copper tank and the filler bowl and ready to fill into the container. We use high pressure inside the copper tank and the filler bowl to prevent CO2 release. And the filler bowl, the one system, the finished syrup flow to the one system into the container. And finally, go to cement. This is the fastest CD fuel cycle. In the front end, we use CO2 to lay on oxygen inside the container. It helps to prevent oxidation after fueling. In that tube, we did it for a vessel with the filler bowl. In that jeep, the one outward and syrup tank to pour into the container and take a vessel to reverse forming. In that part, the vessel is ready to pour with atmosphere. Many people think that the fueling cycle is here. However, there is a wait time identified to exchange syrup and CO2 and no time to stabilize before going outside. The following issue is covered to factor in that key the waiting time and identify the waiting time in a suit level. So, when we need to use high pressure and low fueling temperature during the fueling process. And you can see the fuel at higher temperature, CO2 will move faster. Therefore, the CO2 absorption will decrease in high temperature. This indicates so that when the ratio decreases, CO2 absorbs more effectively. For this new information, we have to use high ratio and the fuel bowl and low fueling temperature to maintain CO2 absorption inside the finished tube. Now, this video visualizes the fastest CD fuel cycle. This is one created you ratio cycle. The G chữ tảng bỏ into the container. Then for anything and then find the waiting time. After the trend, the fueling process, we do the first channel to read the applicant confirm and we fail. And you can see the forming issue happen in order to go out of the fuel bowl. At the time, we only read the chiller and mixer and in on order parameter the same. Therefore, we believe that only the temperature without any fighting is not good solution. We need to dive into the forming issue and define solution where we could go. Ultimately, to find solution.
So to understand more about the foaming issue, we apply the principle new approach. So our principle is no foaming issue when fueling at 18 degrees C and refer to the OEM manual book, their foaming rules. The first one is using suitable fuelable pressure, fuelable level, and the pressurization and lifting process must be effective. And we see all that is good as we all follow the OEM guidelines and also all the measurement was conducted using validated devices. However, for the last rule, CO2 absorbed effectively into this product after fueling. We see that this rule is not good because the CO2 contents all finished product fail the lower target after we increase the fueling temperature to 18 degrees C. And to find out the root cause, we next apply the firewire analysis on this last rule. So the issue statement is, since the fueler cannot operate at 18 degrees C, This is because the CO2 content in finished product always have the lower target. So why this happen? This is because CO2 in syrup release very quickly after filling at 18 degrees C, high temperature. We already know that when the temperature increase, CO2 inside syrup move faster, but under the same pouring time. It means that the speed of syrup flow into container is the same, but the CO2 inside syrup move faster due to high temperatures. Therefore, it will hit the container harder and release very quickly after filling. And this is our root cause. The pouring time remains the same, even though the filling temperature increased from 13 to 18 degrees C. And to have more insights about that, our team conduct 2 experiments as well. So the first one, we pour 2 CSD can at different temperature at the same speed, and let's see what happens. So you can focus on the second one, the one with high temperature, and we can see that this is with more foaming, and we conclude that under the same pouring speed, high temperature causes more foaming, and it's the same with our root cause statement. In the second experiment, we use 2 cans both at high temperature, but we pour it at different speed. And this can be seen clearly that the one on the right with high speed will have higher foaming. The foaming is much more serious. So our second conclusion is that even after we increase the temperature, low pouring speed causes less foaming. And from these 2 information, we conclude the solution for our foaming issue must be to reduce the pouring speed. And then when we reapply it, when we reflect this to the 60 filling cycle, to reduce the pouring speed means to extend the pouring time. This step number 3 here. So let's imagine that when the volumes of our product is kept the same, when we extend the pouring time, it means that the speed of syrup flow into container will be slower. And this is exactly what we want. But how to do that? We have 3 options. The first one is to reduce the speed of filler. So this will extend the time of the whole cycle. But it also hurt the line efficiency, so we will not go with this one. The second option is to reduce the volume of our product. We cannot do that also because it violates our legal. But for the last option, we can reduce the waiting time, step number 5, and then we can use that extra time to add right in step number 3, pouring time. So by doing this, we can extend step number 3, but the total time for one cycle is the same. And this is our Kaizen. So this has no impact to the speed of filler. It's no investment, using only internal resource, and also the result comes immediately. So our project starts in March 24 and ends by the 3rd week of April. And start with the FOC. We identify format risk, and based on that, to be the testing protocol as follows. We will continuously tracking the CO2 content, net content, and O2 content during trial, together with the product temperature after warm-up. And finally, we conduct a 30-minute downtime simulation at filler to ensure that our filler bowl will not get unstable after a long downtime. So this is our filler bowl before Kaizen. The syrup is at 13 degrees C, the bowl level is 60%, and the test plate contains CO2 at high pressure. For the filling cycle, the time measurement of this step can be seen from the HMI screen. And our action is to reduce the waiting time, step 5, and then we do the extra time to add in step 3 to make the total time for one cycle is the same. But how to do that? Based on the machine design and also the filling mechanism, the only way to do that is to reduce the filler bowl level. So this part over here. So let's imagine that when there is less water inside a tank, it is less heavy. So when the valves open, the speed of water flowing outside will be slower due to lower gravity. So this is what we do. This is quick, it's easy, and it's also low risk. So now please focus on these 2 pictures. We have prepared some animation to make it more visual and easy to understand. So, okay, so you can see that, right? What we do is to reduce the bowl level from 60 to 50%. And by doing that, the pouring time also increased by 0.5%, by 0.5 seconds, from 3.9 to 4.4. And the waiting time reduced respectively. The total time for one cycle is the same. And this is what we do. It might look easy, but it's actually a fine-tuning process to achieve this. And below or above this 4.4 seconds, the foaming issue will definitely happens. So yeah, it's time to evaluate the mix. Now this is the machine setting before and after Kaizen. So the mixer temperature increased from 12 to 16. The filler temperature increased from 13 to 18. The bowl level is reduced from 60 to 50%. So to evaluate the results, Arctic successfully increased the filling temperature from 13 to 18 degrees C without any quality issue. So that means we achieved the yet target setting at the beginning. However, our Kaizen not end here yet. After successfully increased the filling temperature to 18 degrees C, we see a risk that our product temperature after 1 month also increased from around 29 degrees C to around 30 degrees C. Consider the normal condition at Vietnam. This data is still in range. However, is there any opportunities here? Is it necessary to keep the warmer temperature the same at 40.4 degrees C, even after we increase the filling temperature? So to answer that, we apply the principal rule approach. The principle is product temperature after 1 month is in control between 28 to 51 degrees C, and we have two rules: filling temperature at 13 degrees C and warmer temperature at 40.4. However, after increase the filling temperature to 18 degrees C, we see that it is not necessary to maintain the warmer temperature too high at 40.4, and this is an extra opportunity for us to save more energy, and we do that. So after fine-tuning, we successfully reduced this temperature to 38.5 degrees C. The product temperature after 1 month is stable at around 29.3, and we save 36% of steam consumption at 1 month. So with that, we successfully deliver this Kaizen for the can cold field, and now it's time to lift and shift for the can cold field. So what's the difference between those two? For the can cold field, the filler bowl was designed with only 60% of syrup inside the bowl, and the head plate contains CO2 at high pressure. So to control the cooling time, we need to reduce the filler bowl level. And this is the KS design. But for like that cold field, it's from Shidell supplier. So the filler bowl was designed with no head plate. This means that the syrup will occupy 100% inside the bowl. And to control the cooling time, the only way is to control the speed of the syrup supply pump, the power of that pump. And so therefore, to apply the same principle for two suppliers, for KHS, we need to reduce the filler bowl level. But for the Shidell supplier, we need to reduce the speed of the syrup supply pump. And this is how we did it. So after fine-tuning, we reduce the speed of this pump from 400 millibars to around 380 millibars. And by doing that, we increase the filling temperature from 13 degrees C to not only 18 degrees C, but also last 2 weeks, we just reached 2000 degrees C, exceed the original target that we set at the beginning, which during hot moment become the best practice for filling temperature at Vietnam. And it's a big win for us. So in conclusion, this project helped to reduce 60% of electricity consumption at chiller CSD. For the steam, it's at 56% of steam consumption at Walmart. And all of this can be translated into 1 billion Vietnam dong per year. It's around $55 assets. So after that, we train MOC and also OBL, and then conduct training to online technicians to ensure they all understand the new process. So to review the process, for the export effect, this project successfully delivered 1.15% of total electricity reduction at our plant. And more specifically, it's about 3.2% for the can cold field and 2.2% for the cat cold field. All of this is equal to more than 200 tons of CO2 emission per year. It's like planting 9,000 trees in Ho Chi Minh City. And for the intangible effect, this helped in develop on-site game capabilities, crafting people, and more specifically, continuous technological innovation by successfully increase the filling temperature to 20 degrees C without any investment. And more importantly, the power of this project is through leadership and reapplication. Because if we just understand the filling mechanism of the city filling cycle and then flexibly reapply the principle, which is to increase the cooling time and reduce the cooling speed, and then this project can be very easily reapplied to all the machine model from different OEM. So this is the true power of this one. So challenge for the future. We will continue to differentiate this Kaizen for the high CR problem products, and then cross-sharing this one to all 5 lens in SBFAP. And then this is the very first step to prepare for our low time cycle in 2026. So that's all. Thank you very much for your attention.
Thank you, Vin and Tung. So let's take some questions from the audience.
Thank you for the presentation. This is very great projects. It's actually in SBBT we are now studying on the ambient field. So this kind of we try to explore the technology on the ambient field, but it's just only the question that in terms of product quality. There's some we really concerned when we are studying on the ambient field when we put the product in the market. So have you done the study of the CO2 study on the trade? Like really reach to the CO2 level in the trade or not?
So you mean the CO2 retention?
Right, exactly. So the CO2 retention in the market.
So actually we complete this project in April this year, and in our QC department we also have the CO2 retention every month for every month, and up to now there's no abnormalities in the trend, so I think that's okay. And also during the testing protocol, we also control the CO2, O2, and also the reactant. Everything is normal. Yeah, so that's my answer.
Yeah, thank you. So it's actually in your testing protocol, it's not like the parameter for the release. This project is not like CO2 retention for 7 weeks. Not that, right? It's released right away.
Yeah, in the protocol, there is short run for 1 month, and then after that, it's long run, short run for 1 week, and long run for 1 month, and then commercialization. So yes, this is in the project.
Okay, so Mexico also approved on this protocol, right? No, it's a question, but it can challenge.
Yes, currently it's in step 7.
Okay, thank you. So I can have red line now.
Yeah, if I can just add, thank you. So I think if I can just add to that, I think the main question was at the market, if anyone would survey and then check what is the actual condition of this product at the market.
Let me check back, but currently, from my knowledge, from my experience, from my memory, it's no. So I'll make sure to capture that in the next one.
Thank you. Right, any other question?
Thank you. I think it's very good presentation. I like the storyline. And even for a person which is not very technical, I think the way you explain it is actually very, very good. Right? And I think it's also sure that you really understand the machine. Right? It is what I like is basically the problem looks very complex, but after you really understand what is the issue, the solution is actually looks simple. But it's actually, I believe behind it, you did all of the study in order to reduce the boiling time of the 0.5 second, increase the waiting time of the plus 0.5 second in order to ensure the quality is actually is not compromised. So it's not a question. I just want to give the comment. Another thing that I really like to see is actually I feel the strong interdisciplinary spirit from here. You face the problem, you propose the solution. You face another problem, you see that there is another opportunity in terms of reducing the steam consumption. You did it, and even until now, you still try to find another improvement. Thank you so much.
Just one comment and question. Stating, thank you so much for your presentation. I like your starting point. So you try to look at other sites. So starting from benchmarking, so that's a very good point. So as you mentioned, SBFAP also doing a lot of activity for the unmet clinic. So yeah, this kind of new technology and also this kind of Kaizen activity will give us more opportunity for improvement for future. So that's my first comment. My big question is, when you change the pouring time, from the current one to 4.4, you put a successful story. But when it comes to 4.5, so you saw the core, right?
Yes.
So can you just briefly explain what was the report?
Yes. Okay. It is slide number 19. Yeah, this one. So, so this is the CC building cycle, and our project is to increase the cooling time, right? But to keep the total tempo one cycle is the same. So the step number 3 increased, the step number 5 must be decreased. Yeah. So this is the waiting time, and the waiting time is used for the products and also the CO2. We have time to stable after peeling it all the way down. So if this step is too low, this becomes unstable and forming issue will happen. So this is my answer.
Okay, thank you. So yeah, that's also my understanding. Yeah, but thanks so much for
Yeah, thank you.
Thank you.
Thank you, Akira. Any question from online? Go ahead.
Thank you very much. Very interesting topic. I have one question and one question for the team. Question for you is when for the CDL line, you reduce the pump pressure.
Yes.
Okay. But once you reduce down the pump pressure, it means the supply serum into the filling bowl is reduced as well. So how do you ensure that this enough in order just to fill the syrup into the bottle without any like air gap in the filling bowl?
Yeah, thank you. So in GDM line and also in KHS line, the principle is just one, is just to increase the cooling time here. So in GDM line, we reduce the pump pressure, but we have to ensure that as long as the bottle go here and then it's go out here, in that time period, the volume of the syrup flow is enough to fill that bottle. So this is what we ensure. If we reduce the speed of that pump too much, so this is the case that you mentioned, that is not enough syrup inside the bottle. So this is what we try to avoid. So that's why in the protocol, there is one testing. This is to test the net contents of all the product coming outside. Yeah. So yeah, we can extend the cooling time. There is the threshold.
Thank you. And another question for me is because you mentioned in the beginning that the new line that if we can invest, so we can increase up to 23, 24 degrees C, right? In the very first beginning.
Yeah.
So I just maybe just question to just to the team that whatever the line that we invest in the future, we should go into that direction, starting to invest in the beginning and get to 23 very easy, right? Just ask it.
All the lines are fire on.
Okay. So it's gonna be 23.
Yeah, 20 degrees. So
okay. So then
technology's changed.
Right. And how much that investment need in order to just upgrading the current into the MVP? Is it worth to just upgrade it now?
Or you mean change the product? Yeah, we have to justify it.
Yeah.
It's expensive.
Thank you, Subasa.
Yeah.
Okay, Ian, please go ahead.
It's not so much a question, but more of a comment for these amazing projects. In the assessment of value, one thing for people or for the teams to keep in mind is the level of in-house technical skill to drive these improvements. Other companies would be paying external experts or OEMs to do this work. So just to call out that when you value the benefits, don't forget the cost avoidance of doing this work yourself as opposed to paying somebody else to do the work. So it's not a question, more of a comment, because these projects, in terms of implementation, are saving saving us a lot of money in terms of having to rely on other parties to do the job. So I think that was just worth highlighting.
Yeah, thank you. Definitely.
Yeah, thank you.
Good comment. Right. So I have one question for the type of product, right? So we have a sugar product and a non-sugar product. Is it different when you come to like a non-sugar product or artificial sugar product compared to sugar product? Does it react differently in terms of foaming?
So right now in SBB there is no sugar product which is F0, and this is I think so for now for our clarification we just split between the low gas balloon products and high gas balloon products, and all the no sugar products happen to be all high gas balloon products. So if this is high gas balloon products, it will have a higher risk of forming because there's so many CO2 inside the syrup. And yeah, the risk is also higher. So that's my answer. Actually, in reality, this Kaizen is applied for only the low gas balloon products, but we also study for the high gas balloon also. For 7-Up, we already successful to operate at 18 degrees C, but just in normal operation. And when at the end of the downtime test, when the filler ball has downtime like just 15 minutes, then it starts back, the foaming issue will happen. And so in reality, this is what we're facing now. And for that, we can currently have two solutions. The first one is maybe we just spend more time to ramp up after a long downtime. So the cooling speed will be much slower. So there's no foaming issue. And another option is to increase the CO2 pressure inside the filler ball. So this is to keep the CO2 more stronger inside the syrup. So there's two options. The second option to increase the CO2 pressure, it will impact to the CO2. So there are two options. It's called capture and hold. But we make sure to capture these two options into the next round. Yeah.
Right. So thank you. I think that's all for you. Thank you very much. Good project, Mr. Vin and Mr. Tu. Right, so we are bringing for lunch. Right, so let's be back. Singapore time 1:50. Right, enjoy your lunch. Thank you. And the food is outside, same pace.
shortest time, turning time, and the longest microbial count in CFU. Finally, we find it accelerates CF performance best. We successfully shorter CIP time from 50 to 105 minutes, and the making whole CIP time from 17 minutes to 175 minutes. Second, we obtain blending delay. In this Kaizen, we double filtration capacity. In blending process, we find blending delay increase more than double from 40 to be over 18.760
sterilization temperature, sterilization conditions for the drink cover were changed. What kind of quality evaluation was done, particularly with regards to the caps? If there was any adverse impact on the capping performance of the caps themselves.
Actually, for all the validation process, we collaborate not only with QA, PD, and also the Taiwan government authority. So we can collaborate all the way and confirm the condition can be guaranteed and no impact to get.
So the cap itself, there's some rusting and any issues, there was nothing found. That was no issue.
Impact to get.
One more question. Did you benchmark with Kaizen as these changes were done?
You mean only benchmark, right?
In terms of the settings, neutral conditions, risk levy programs.
And all the areas, we call condition was 131 degree. It's high heat. If we know we can see the highest sterilization temperature. Or more detail.
Maybe it's good to have the benchmarking. So from a CIP perspective, what chemicals we're using, what programs we're using, that benchmarking now. And conclusions.
Yeah, thank you.
Yeah. Thank you for the presentation. I think it's good to see the progress in terms of the OE. Sarah, can we go to the slide number 51?
51.
Yeah. So 31. Yeah, this one. So I think it's basically the OE is improved, right? Go to the 73.8. But if I see from the week-to-week performance, the fluctuation is still quite high. I mean, it's every 4 to 5 weeks, we see it's coming down, then going up again, above 50%, coming down and going up again. And so my question is, do we understand what is the reason for this fluctuation? And the second one is basically, what do we do in order to stabilize the variability of this OE?
I have present our losses was from the effect downtime. In some weekends we have the downtime, and in some weekends because it's produced current assets, it need more CID time, so the OE was low. Because the claim assets take longer for attacking the strong order. When you production claim assets, the OE has only 66%.
Thank you.
Right, we have a question here from the audience as well.
So we're not the judge, I just have an interesting question. I'm not the judge. So I understand that you show your ad-hoc value with a higher temperature, this will lower treatment time. So as you know that your process is currently sterilization. So when you impose your sterilization on a higher temperature, you will have in food science, you might cause some loss of macronutrients in the chicken essence. So how do you validate that your sterilization process did not lead to the loss?
We have HFC. Doing that. Yes, yeah, we guarantee the S0 stay always the same. You mean for the food safety guarantee? Good questions.
Let's say that because you can go to a high school, let's say that your need to go to this energy or go to your high stabilization system. You may have in some other way contributing to unit or reduce for that. So how did you validate that your need stabilization? Let's say to declare or at least macronutrient in chicken method. After this treatment, based on this chemical, how do you validate that your need is still sustained despite high treatment in an attempt to master weight?
Excuse me. Last words. How to guarantee what? And we have always been collaborating with PD and QA to guarantee no matter for sterilization condition and flavor test, etc.
So you did do the PQ on the macronutrient stabilization.
Next week one.
Yeah, you have a question? Go ahead.
This may have been asked because it's a bit hard to hear, but just two questions really quickly. So this project, excellent project, generated significant savings, about I think it's 2.3, 2.4 million US dollars. Just the addition of that filter that was discussed to unlock capacity, what was that investment cost?
For new investment, we only invest the other new field. Filter, sorry.
How much?
Sorry, for the filter detail, we need to check out.
I agree. This capacity is large.
Just to clarify, I think on the Excel spreadsheet, there was a saving of a huge amount of like 2+ million. Actually, this was released capacity to be able to meet the top line. Actually, if you go to the slide, I think they mentioned that the saving is, I think, then over there, about 12,000 you count hard saving, the labor hour and the detergent. So that's actually the saving. So I think the savings in the Excel is more of sales avoidance and everything. Yeah, so just to clarify.
Yeah, the growth capacity.
Yeah. Yeah, we free up more capacity because we are running non-stop for our one shift operation.
Yeah, maybe one question, because you know that the report, when you can go up to 121, but you stop at 118. What is the reason for not up to 121?
Actually, it's on the formula, and our report was not 131 degree because it's over 30 years. It's 10x. It's like my brother.
So if for the next step, if you have the money to invest, would you go to 121 or you still keep it 118?
We will still for the 118 because in our previous speed was only 40 to 30, but means is can the capability is can form a field.
You can say now the bottleneck is the retort. But if the retort improves, then the bottleneck may turn back to feeding.
Right, thank you for the question. So can we take one more question?
I think it's very impressed on the OED improvements. However, will you clarify the contribution from pre-bank? You had CAE improvement, you had margin improvement, and you also had report. So how many percent contribution from each of the improvement? So you get from the OED?
Okay, it's here. The full bar was the setting, and the origin bar was the changeover. And the brain.
Can I suggest that maybe he speak in Mandarin, then Jim can translate?
Yeah, sure.
Yeah, so you still will solve lang Jim I find it. Because English is challenging.
Gray is the blending delay. The blue one is the CIPC. And we improved from the beginning 31.6 down to 23.1.
So I have another question regarding to the design of the line. So because you said that return, is lower than the fuel speed, right? So because of the downtime, so you have to to increase the temperature and reduce the time. So why don't you fit the downtime so you can maintain the current student? Instead of change the temperature, then the remote temperature. Can you fit the downtime issue so that you can improve the remote speed?
In this project, no specific improvement in downtime, but we have three focus: blending, retort.
Yeah, I mean the reform, right? So you improve the reform to the bottleneck of the line performance.
Yeah.
Because the filler speed higher than the reform.
Yeah.
So you try to the bottleneck by increase the reform temperature and reduce the time.
Yes.
So that you can the bottleneck. As my question that if you don't increase the temperature, what is the other way you can improve the reform speed?
Yes.
Maybe we can.
The picture, yeah.
Before we have a heating and plateau, and then final cooling. And actually, we have the other project improve the cooling efficiency. That can also support to decrease the overall time within the cycle.
Okay, thank you.
All right. Let's give a round of applause. Thank you.
Okay,
Okay. Right, so thank you, Taiwan team. The next one is from Mr. Wanlock and Mr. Sambu from SBFAP Riot team. So with their title, the 2050 project.
That's all. Right. So 2050, roughly calculate, I'm still alive actually. Hopefully. So back to you. So the stage is yours.
Well, who say Obama say, we only get one home, we only get one planet. There is no plan B, but the 2050 project is plan A. Hello everyone. First of all, let's introduce ourselves. My name is Walok from Engineering Department.
My name is Jake Sombun from Engineering Department. We are technician of SBFAP Thailand. SBFAP have two factories in Thailand, Rayong and Sabrikan. All plants is in Sabri province. We have 3 lines for CAD and only 1 line for PET NCB in SBFAP Thailand. It produces various ranges of liquid and gasoline. Our project follows the sustainability vision of the Suntory Group to reduce 30% of GHG emission by 2030 and net zero by 2050. SBFAP cascades and builds awareness of GHG reduction target throughout our organization, while still maintain and comply with the Suntory monopoly value, health and safety, and quality policy to get the highest part and confidence of the consumer.
We have an idea after seeing vision from Mr. Takeshi Minami. He talked about go to net zero GHG in year 2050.
Technical problem. Stop the clock. Yeah.
Stop the clock.
Or it could get me in trouble later.
We are pursuing fully sustainable plastic technology for 2030. And we are working to achieve net zero greenhouse gas emission
Zero GHG Mission พี่ต่อครับเราจะมีส่วนร่วมยังไงในการช่วยให้เป็น Zero GHG ดีครับพี่
พี่ก็ยังคิดไม่ออกกันนะเราลองมาดูในแนวผลิตกันดูไหม
ไปครับพี่เผื่อเราจะได้ไอเดียอะไรมาช่วยโลกของเราครับได้ครับผม
กระดาษมันติดบ่อยจังเลยนะเนี่ย
น่าดีพี่เราจะทำยังไงเพื่อที่กำจัดไอ้กระดาษตัวนี้ดีนะ
ไม่ต้องคิดแล้วลงมือทำเลย
ไปพี่
Did you know that from year 21 to July 23, our SBFAP used 2.9 million piece or 169 tons of paper tray, which is 3,200 of trees, equivalent to the height of the 70 stack of the Marina Bay Sands. Function of the paper tray is to support the pack and pallet to be strong and stable during transportation. This is only in Litan 950 and Gatorade 500. As per first product packaging designed from R&D. Over last year, it cost us more than $185,000.
In 2021, we conducted a trial on trade for both sides
But it is past, even though we put a lot of effort. The pallet bottling and pallet building transportation phase. So we are not giving up. We try to set zero target to eliminate 100% of paper tape from our product. Why concern on quality and first priority?
First of all, I would like to explain our production process. The SCP hot fill line starts with finished syrup, transfer to pasteurizer, and then transfer product to filler machine. In the part of the packaging line, start from preform film to ball molder, filler, cooler, sleeper, chin packer, and palletizer. Then after finished product, transfer to warehouse for sale. This project is focused on the packer and palletizer machine. Packer will put bottle on the paper chain with glue and chin film, while palletizer will arrange the pack on the pallets. In the layer and second that fit to the pallets.
This slide shows plan of operation when running the train. Lapping of train and falling under the packer. This is also done. Damaged train creates a lot of weight. Missing transfer paper tape creates the maintenance of the packer machine and need monitoring in the operation time. The good notion often get clogged. This will make the train continue forming and cause to the bottom to fall. Here are 13 quality criteria of the pack which we must comply with, especially criteria number 10. The blue eyes must align with the specification as shown in slideshow.
For the palletizer, we have 7 principles and rules for the pattern design and 7 quality criteria to analyze the layer pattern. We check the layer pattern design, follow the 7 rules, and found one of them. There are 2 gap space in the current pattern of size 950 and 500. For most of SKU not comply with the pallet standard pattern design. The most possible cost of the pack on the pallet was lean and pallet during transportation. We use people with 5M1E to analyze and identify possible root cause with team.
After identifying the team, you go get up, right?
Yes, okay.
How many possible causes after you get up with team?
We got 6 possible root cause, then we also get up on site to verify them, such as hard labor skill, hacker and palletizer center lines, and chip film specification. Finally, the only one remaining possible root cause of pallet leaning during transportation is the pallet pattern design. Then we use verify analysis to find real root cause of lean pallet pattern design, and we got root cause as follows. First, OEM never provide basic pattern design training for us. Second, no specific software to design pattern on the pallet. The design of pack without tape provided by OEM not correct and no layer to develop what of top side dimension. Lastly, OEM apply or design to non-tape pattern.
Before we start 5 action plan for the palletizer, we must to execute our 3 action plan to ensure the pack comply with 13 quality criteria. For the palletizer, we have 5 action plans for identify with team. We have for the project start in February and complete by end of July 2023. For understand for operation, let me explain about the process of the packer machine. After the bottle numbers by sleep method, they are transferred to the bottle in field. They are grouped and fixed with paper tape to support another pack. Then inject glue and tray forming. The machine feeds chip film to wrap and chin the pack.
Here is the action on the packer machine before we implement action on the palletizer. Step A, embark and check hardware and software for non-tape. Step B,
creativity of machine with non-J for both sides and test with the dummy product. Step C. Collaborate with quality team to check and ensure pack comply with 30 quality criteria. All results will pass. After we remove paper check, we can simplify process by eliminating 4 working steps at packer. That means we reduce check over time, electricity, minus stock, maintenance cost, and more.
For the quality testing, we have 5 action plans as follows. 1. We utilize site ecosystem to conduct training program on pallet pattern design for team. 2. We start sheet application for simulation with available software, such as PowerPoint, SketchUp, and AutoCAD. Finally, we selected AutoCAD program as the most applicable for this simulation. 3. Consult and simulate with the new pallet pattern design. We specially follow 7 principles and rules of pallet pattern design. This slide shows the new layer pattern of layer 1 and 2 for both sides for the pallet pattern. The machines will lay down swap pattern layer 1 and 2 on the pallets until pallets complete. In the program, we create working step based on pallet pattern design. While we consider the lines and achieve speed, we curve them up and let down speed of the entire line.
We will finally able to solve a problem that we faced in year 21. For our improvement, we could fit 1 extra pack per layer of ethylene 500, which is gain 6 pack per pallet, and 2 extra pack per layer of Titan 950, which is gain 10 pack per pallet. After we succeed on new pallet pattern design, we conduct a full tryout on both sides, following the quality standard, such as overhead, continuous force, appellant, and etc. Check stability.
I heard it was the Vietnam team that switched it off. Vietnam team that switched off. SBFAP.
I think Alan did not pay the bill.
You pay by half.
People need tools.
Yeah, we just pay for 2 o'clock.
I didn't put that.
You've seen it. You see it. It doesn't.
ยืนคุ้มค่าตัวทุเรียนเลย
เลยเขาให้เลยให้เลยทั้งนี้หรือเราหรือให้เลยเหรอ
เอาไปใช้ตัวไหนดีเพราะว่าใช้ไปเล็กน้อยดีแบบชนความเรียบสายเป็นเรื่อง
There we go.
Okay, so sorry about that technical glitch. So just one question. When you walk at the back door, just be careful not to touch the screen. Just accidentally. Disconnected. Okay, so back to you. I give you back to your offline. Sorry about that technical glitch.
พยายามตั้งกันYeah, there we go.
After we succeed on new pattern design, we conduct a full trial on both sizes, following the quality standard, stamp overhang, containment force, and pallet and etc. Check stability test of the pallet while handling with forklift. Finally, full pallet purchase with transportation as a new product. All tests were passed.
From the video, after the remove tray process, the line can overlay with its nominal speed, complying with all quality criteria, and no minor stop of the packer and polyester machine. After we complete all action plan, the successful results will escalate to demand panel, sales, and marketing team to inform customers about the change and the date for the first commercial production. Moreover, we are taking complaints from consumer and customer. No negative feedback, no recall or withdrawal from our product.
Yes, we did it. 2.9 million sales were removed and $170,000 saving from trade process. We can eliminate paper trade 100%. Moreover, 208 tons of CO2 were eliminated from the entire value chain. Let's update on how can we reduce 208 tons of CO2 out from our entire value chain. Raw material are scope T, state feed, shin feed, paper chain, and glue process generate 122 tons of CO2 relative speed and speed usage. For this process is 19 tons of CO2 on scope 1 and 2. Transportation, waste management, and end of life product is 67 tons of CO2 in scope G. Totally is 208 tons of CO2 emission from the whole process.
When we eliminated paper tape from our process, we were able to reduce GHG emissions as follows: 189 tons of CO2 equivalents of scope 3 from raw material, upstream and downstream transportation, waste management, and end-of-life product. 5 tons of scope 2 from electricity used during machine downtime and forklift operation, and 14 tons of scope 1 from steam loss during the downtime while waiting for the entire line. All were eliminated when no material were used. Zero paper tape is not repent. There is no tree cut down to make the paper tape for our product, and no more issue from paper tape for LCD line. Yes, our hand is success. Number 3, save money, reduce more GHG, and support more vision missions of Mr. Takeshi Minami.
Wow, it's It's a good job and receiving. Yes. Our project impact to business directly. For the environment, we reduce 208 tons of CO2 emission, almost 1,400 kilowatt-hours reduced from process, exactly 100% trade were eliminated from Salisbury plant. On safety, there is zero incident came from operation and maintenance trade process. On quality, we achieve zero in complaint. We achieve zero complaint from consumer, and build more robust pallet during transport.
On deliver, we increased 2.6% of OEE for Gatorade and Lipton, with 23 downtown eliminations, and increased pack per pallet 6 and 10 for Gatorade and Lipton, and relief when our inventory area for more than 1,500 pallets. On top, we could save more than 167,000 US dollars for productivity from the cost of materials, transportation, and maintenance costs. Last model, there is zero reposing and labor pay were incomplete, and 100 satisfaction of a line after limit trade process.
For more effective benefit from our project are improve safety workplace and eliminate economic or social risk. Regulate quality mindset on product quality control and complaint. Release pallet stability during transportation. Reduce changeover and CMP time to 20 minutes. Moreover, eliminate and simplify product complaint with long tail and spare parts.
We helping people with non-tech skill by utilize size equation, real GNG awareness of cost commonly, strive with that minimalistic spirit, and embedded suffering leadership spirit throughout team. Lastly, we build cross-functional teamwork in manufacturing team and bring SBFAP Kaizen improvement to life.
To sustain our project, we convert our improvement with six management of change to allow our change to the whole team. Deliver 4 center lines to maintain performance machine. Engineer and quality team with more than 240 hours of the job training.
Here's the review of process. For good point, we can deliver our project comply with statutory monocyclic value and follow the 2 missions and 4 principles. On our mission, deliver the zero TD from small thing with impact power. Strengthen protect the customer before deliver product to customer. On our principle, eliminate unnecessary waste at first. Enhance pallet utilization with local experts and specialists. Attention and identify the hiding opportunity from impact by our functioning impact program. And lastly, helping people with multi-skill and level up on GNG awareness to all. For improvement points, organize GNG committee and increase engagement from online and drive GNG culture to all SPVT. I think we have a gap for the net zero right. In the near future, what is our next challenge project to support zero GNG?
Yes, our next step is maximize head and weight per pallet to reduce GHG emission to generate more productivity while still comply with regulatory, safety, and quality standards.
2050 net zero. Go together. One Suntory. Thank you for your time to listen our time daily.
Thank you. So sorry for that technical glitch, but I think you guys did very well, and when we started, you started quite well as well. So the first question is from Alan.
Yes.
Excellent presentation, gentlemen. Thank you very much, and congratulations for suffering all the technical problems we had. You did well. I think it's a great project. I love to see package elimination. It's fantastic way to obviously take out cost and take out GHG and CO2, etc. As you were sharing the CO2 savings, you also mentioned shrink and stretch. But I didn't see how we reduced the shrink and stretch in the project. Shrink film and the stretch film.
ไม่เห็นว่าสิ่งที่เราในโปรเจกต์เราแชร์วิธีเราแชร์สเตชันเนี่ยนะแต่เนี่ยจำที่บอกว่าช่วยสเปรย์อะไรมันเปอร์เซ็นต์ตรงไหนจำก่อนได้ว่าเราปีช่วยสเตชันที่เราเลือกความยาวถึงแม้เราต้องปีอะไร
For the packer, we reduced rate of pack shipping fee packs. It's, for the white list is reduced 75 millimeters, and for and for 950 millimeters reduced from 35 millimeters. And personally, from calculus for India, reduce 6 times.
Okay, very good.
Or for only packer, for the stress vapor, we reduce from we utilize the pallet. We increase packer pallet and
increase packer pallet means reduce numbers of pallets.
Did you reduce the grammage per pallet, for example?
No, we didn't reduce, but in terms of the pallet, you get
more cases. Okay. So basically more cases per pallet.
Yes,
very good. That was when okay. So in terms of productivity per pallet. Okay, very good, excellent. And I wanted to touch base on that as well. I think it's a fantastic project that not only did you look at taking out the carton packaging, but you looked at your pallets, you looked at cases per pallet, and that has a knock-on effect throughout the entire supply chain because you freed up 1,500 pallet places in the warehouse. And I know how much that constrained the warehouses and that was an excellent project from that perspective. So really well done. Congratulations.
Thank you.
And you look amazing as well.
Thank you, guys. By the way, I thought you were from the brand scene. So, out of curiosity, just one simple question. How did you convince the sales team to go paper and traders? How did you convince the sales team to go tradeless?
Good question.
Sorry, time.
Thai language. Thank you for your question. ในอันนี้เรามีการเข้าไปแจ้งเซลล์ครับผ่านตัวทางเซลล์ทางทีมเซลล์ของเราก็ว่าเราสามารถทำตัวนี้ได้ทั้งหมดครอบคลุมแล้วโดยผ่านเทสจาก quality ก็คือ1จาก quality criteria ครับทั้ง13ข้อรวมถึง7 principles and rule of the pallet is the comply of
we convinced them. Actually, we convinced them by tell them that the other products also work because we have the other product not use tape and our product as well they not use tape. Our new our these 2 SKU also comply with 13 quality rules and 7 quality rules of the pallet and packer. So they believe on that one. And internal test also passed. Transportation, containment force,
is all passed.
Thank you. I think there's not an easy way work to convince sales and marketing. They always convince us, not the other way. Anyway, right. So we have one question from Ian. Ian, go ahead.
Maybe the same subject. And just to start, if there were points for best dress, you would get the points. You look great. In terms of the product going into the market on the shelf, does it go on the customer's shelf? How have the customers reacted to the change by removing the tray?
Thank you for your question. In the slide, turn to me. After we complete this project, we taking complaint from customer and consumer. They have no complaint, no negative feedback, no recall or withdraw from our product. Yes. No surprise.
Is that okay, Ian?
Yeah, I mean, in our market, you would need to put that product on a shelf and the customer wouldn't want to unpack the units and put them on the shelf individually. They'd want it on a tray. So I'm just interested in the difference, that's all.
Got it. Okay, so that's just a comment. So basically market by market, there will be different preferences from customer. So it looks like the Thai customers like more acceptable to this method. So that was the question. Right, thank you, Ian. Right, so any other question from anyone else? Audience?
A simple question. So you tried this one in the past, 2021, and you failed it. And you apply this project now. So what happened after 2021? So actually, why you didn't do this trial at that time? So any reason behind?
Your question is what happened during that time?
Yeah, simple question. So why didn't you apply activity at that time or any reason?
Thank you for your question. On this time, we have no site partner and we don't have knowledge. In 2021, we used OEM to do this project. We don't buy ourselves. Same like 2023. In 2023, we have the site expert to send the knowledge for us.
So simply, your team has been much more mature than before, and then you try to do these campaigns rather than relying on the OEM people.
Correct.
Fantastic. Good.
If you can actually take one last question, if there's any. Microsoft team, anyone? Any questions? Chat box, no? Right. I think if there's none, I think thank you very much.
That's what is for uniform.
If there was an award for best dress, right, there should also be an award for creative presentation titles. We have turning off into off, shooting star, and we have roll with the punches. Is that Sylvester Stallone?
Yeah, Rocky.
Yes, Rocky, right? All right, so we hand over to the SBF Taiwan team. Roll with the punches by Kevin and Evan. Round of applause.
Hello, everyone. Ladies and gentlemen, my name is Kevin, and this is my partner Kevin. We are from SBF Taiwan Bakery. I invited you here today to have a look at our team. Grow with punch. Presenter introduction. Kevin and I both come from production. We need to force switching, especially during the middle and night shift. We need to perform some processor operation personally. Our position is supervisor, and we have been in Suntory for over 4 years. This is the outline. We use the Kaizen steps here to unify what we do.
Step 1. In 2023, we have a big event in grants. We are excited to launch BC 2.0 in May 2023. Before BC 2.0, we have been studying BC 1.0 for over 200 years. BC 2.0 is a big milestone for grants. This is the first time to tackle the test barrier. The level of BC 2.0 becomes better, and the cost of raw materials also become more competitive. High expectation from management team, and all parties are waiting for good news. However, at the factory, we encounter an unsteady situation. Daily output drops severely. Daily output drops 45% to 80,000 to 9,900. The actual production quantity of the battery cannot meet the demand, and it's difficult to distribute goods in the market. As a result, NSB in Q3 and Q4 failed to meet expectations. The maximum difference in Q3 and Q4 for the sum of the gap was over $4.33 million. Even in the difficult time, we still adhere to the mono definitions and the principle as fundamental of our projects, especially with the two aspects of our mission: creating new value and creating safe, reliable, and high-quality products. Affecting quality, cost, and delivery. SBFAP Taiwan become many trends. We found solutions through SBFAP. Since the BC 2.0, we found performance loss decreased by over 20%. We deploy performance loss. Pending delay is the majority as the green bar on the left. When we go deeper to see pending delay, we found that the reason comes from production delay. Production time increased 67%. Production time increase means we must delay delivery. So in step 3, we set two targets. One is production delay, eradicated to 50%. The other is to overcome delivery price to turn daily output back to 80,000. Step 4, at the beginning, let me quickly introduce the BC process. First, enter receiving portion. We mix it into pieces with mixer. Second, cook with high pressure and temperature for 10 hours. Third, chili oil meat and small particles. Then, separate oil from chicken essence. Next, filtrate small oil chicken joints from cooked filter. And then, concentrate chicken essence with a thermometer. Afterward, filtrate by filter second time to achieve standard validity. Finally, blended BAC that mix spec and start feeding. We deploy all processes step by step and find BC 1.0 to 2.0 difference. First, we check the chicken ratio. There is a big difference in chicken ratio. In formula of BC 2.0 versus 1.0, chicken breasts are reduced by 14%, and no more than quotas. Portion value usage much increased by 71%. Then we test different effect of reaching size, and the data show there is no difference between reaching size and the validity. Then it's essential program. BC 2.0 at a release station, which is supporting the BC 2.0 to provide more energy for better expression. Time and temperature settings are different. There is a station in the red area, where the temperature is always higher. Next is C. We recall the weight of an irresolute, and there was no difference from BC 1.0 to 2.0. Next step is separation. In this step, we find what is interesting is that chicken oil separated from BC 2.0 is less than 1.0. It seems that BC 2.0 chicken oil is reduced. But the actual situation is because there is about 40% chicken oil cannot be separated by separator. Next is filtration. Choosing the proper dynamite can reduce the filtration time. But the error testing, there is no difference between filtration time of dynamite. One different base numbers was higher in BC 2.0. In final spec, let's take a look at the spec. The spec for BC 1.0 and 2.0 has actually pH. But there is no change in base and stability. However, reducing stability has become the biggest change for BC 2.0. NTU is the biggest factor affecting the bending and fluctuating time. So we observe the NTU change in all phases between EC 1.0 and 2.0 as below. NTU 2.0 so much higher than 1.0. Fluctuating time becomes longer with mass to 47%, causing fluctuating delay. As in F1 racing, this is an unfair game and starting point are quite different. It took much longer time in BC 2.0 to reach endpoint. Next, Kevin will show you the powering step.
Okay, ladies and gentlemen, good afternoon. I'm Kevin. And the next step is root cause analysis. And we use the 4N fishbone to organize the cause. And according to our previous experimental data, we can rule out some of the cause. And then BC 2.0 poultry proportion and the cooking program are the basic formula, so cannot be changed as well. So we rule out these two codes. Then we use the YY analysis to find out the root cause. So during the root cause, we find the biggest problem is why were NPD trial aware of the longer blending time in actual production? And that is because of the cost consideration. The plant trial only tests about 2,000 kilograms of BC 2.0, while the actual production size is 6,000 kilograms. This result in the chicken oil is output during the plant trial is less than the actual production. So we didn't observe the chicken oil output exceeds the limit of the separator. And when the separator cannot completely remove the chicken oil, it can be only processed by the filter press, that result in longer filtration time. So here's the root cause. The plant trial volume was less than the actual production volume, which result in a failure to observe the limit of the separator capacity during the new production development process. So in the step 6, we do a 2 Kaizen to overcome the root cause. Here is the first Kaizen about the separator optimize. In the past, we thought controlling the flow rate to decrease the flow rate will enhance the handling time of EOC in the separator. You can see the EOC coming and in the separator to remove the oil. But we found that when the flow rate decrease also make the separation become a bottleneck. So which means the oil separator capacity is not enough for the BC 2.0. So we are still thinking a new separator for more capacity. However, after installing a new separator, the effect of the separator is not as good as expected in first. We are thinking we must unknow something or forgot something to optimize the parameter. So we asked the supplier and to do literature research. We found an impact factor that can optimize the separator, which is back pressure. This is the benefit of back pressure in separator. By adjusting, sorry, okay. By adjusting the inlet flow rate and the outlet valve, we can change the back pressure to enhance or decrease the handling time of EOC in the separator. So it can keep the back pressure can easy to separate oil and water phase to stabilize the oil water interface in the three-phase separation. So in the after test, we decided to use 7 bar as the back pressure condition in our new production process. And also we can decrease and we can reduce for 93% turbidity after separation. Then, before going to the second Kaizen, here's a little story, true story. One day I went to on a date with my wife and go to a Japanese restaurant and I eat a lot of food like including the miso soup. And after enjoying all of the food and I come back to drink the soup and I found the miso soup is like this. There's a layer and a sediment in the bottom of the soup. So when I stir with it with a spoon, it returns to normal. Here. This reminds me of the BEC production process. Okay, what if I keep the EOC in a buffer tank for a longer time? Well, the meat residue and sugar oil become separate in the layer. Furthermore, to reduce the turbidity. So we do a test. As you can see, increase the retention time, the layer become more obvious of the EOC. So here is the Kaizen 2. This is the flow chart before the Kaizen. In the left, A10 is for EOC for discharging and the retention. Then, because of the retention and the discharging were in the same tank, when discharging, the discharging force will disturb the retained EOC, and the EOC and the sugar oil will mix well into an emulsion. Then, the emulsion will pass through the separation and increase the turbidity in the following process. So, we added a new buffer tank for retention. Yes, and in the entrance of the buffer tank, we also special design an elbow pipeline to face the wall and to decrease the inlet force to make the EOC retention peaceful. And then we successfully decreased 45% turbidity after the retention. So after these 2 Kaizen, we successfully decreased 45% after retention and decreased 93% after separation. We finally terminate the purification delay in December last year. And we reached 18,000 as well after this Kaizen. So cheer. So this is the business impact of the Kaizen. After restoring 18,000 daily output, we overcome the demand BEC 2.0 demand crisis. We can also driving a new performance of $4.33 million US per year. And then after Kaizen, the filter end consumption is decreased. Can save the cost, reduce 60,000 US per year, and the burning time also decreased. The man hour also reduced 2,000 hours per year. So step 8. Okay, this is our team with me and the operator and some engineer and the supplier engineer. We use the SOP modification, operator training, and more game model to stabilization this Kaizen to make sure everybody follow the new Kaizen and do the right thing. So let's review about what we achieved the SMB of this in this Kaizen. Okay, we successfully launched the BC 2.0 and overcome the production bottleneck in this Kaizen. So we finished our monoscreen mission. And with cooperation with the various department as soon as the process floor, then we propose the Kaizen and solve the problem to follow the monoscreen principle. Yeah, we did it. And this is the challenge for future. This is the current filtration. We use the filter press in the filtration. And here is we are proposed to upgrade to the calorifer, which can support us for continuously operation. And second, without filter app, can save $160,000 per year. Yeah. So thank you for your attention, and don't forget putting my QR code.
So judges, we have extra points for the sound effect and the effect. Absolutely.
Okay, so excellent presentation. I'm very aware of this project because Chris used to phone me every week, telling me about the out of stock situation we had in the market, so I'm very familiar with the project. I just want to clarify on the 4 million. So the 4 million was
For business loss.
business loss. So we recovered 4 million in SV.
Yeah.
When we were back.
Correct.
Okay, excellent, well done.
Yeah.
Congratulations.
So the 4 million was lost sale and then 60,000 is cost.
Yeah.
Because we reduced the fuel, that one, yeah.
Yeah, okay. I mean, to recover 4 million in revenue is fantastic as well. Well done. Root cause? What was the root cause of the problem?
These problems.
Sorry, I can say that because Kindi also helped us a lot on this kind. So I can say that.
Anyway, very, very good project. Well done. Congratulations. Maybe?
No, he's just holding the.
Oh, he's just holding it.
You don't even know how to do it.
I could have just handed it to him.
Yeah. Right, thank you so much for your presentation. I really like your, the story about Misosu. I'm Japanese. So, just quick question. Okay, you introduced the additional tank, retention tank, right?
Yes.
How long do you keep the bunches or keep the liquids in the
Before Kaizen, because in the same tank and because of the limit of the volume of the water tank, we only keep in to 20 minutes. But after the Kaizen for 1 hour.
1 hour.
Yeah, 1 hour. Yeah.
So the total duration of the bunching has been increased for
Yes. Yes.
but it wouldn't affect any loss or something in the production.
Actually, we have more yield from this Kaizen.
Right.
Yeah, because we can because the emulsion layer can be separate when after the retention. And so we can earn more EOC from this Kaizen. Yeah, but the data not showing this.
Okay, understood. Yeah, great.
I have a question. So basically you have the bottle tank going from 20 minutes to 60 minutes.
Yes.
Did you go through a structured DOE? How do you come up with the 60 minutes?
Actually, the 16 minutes because of this is the maximum I can retain in this, or otherwise will become the bottleneck to delay the following process. Yeah.
Thank you.
A very good suggestion. Thank you. And I can be long to enhance to 1 hour. And the separator is a Kaizen for support this long time. the separator become more capacity, so we have more time to retention the AOC.
Thank you. So Akira-san, so do they get the CapEx approved for the clarifier?
Not yet. Not yet. I'm not being convinced yet.
All right, any other questions from the floor? Yeah, very quiet behind there. Judges? All right. Okay, if there's no further questions, thank you so much, team. And yeah, I like we did it, you know.
Yeah.
Yeah. Thank you.
Right, so we lost some time and then we gained back. Thanks to this team actually, last question to them. So, we are going to break again, a coffee break, 15 minutes. And please be back, Singapore time, 3 o'clock. Okay, so we have a slightly little bit different more time for the coffee break, 10 minutes, to be precise. Okay, so see you back at 3 o'clock Singapore time. Thank you.
Oh, new logo. Yeah, I've seen.
This.
Save the world. Oh. Okay, very good. Yes, very good. So I think about the India. Box in a box in a box. No, box. See.
It's different. Now it's GC 2.0 in Thailand is different in some subsidies. It's very less mission. Have you noticed? Have you noticed the difference? I have 1.0 to 2.0 and I try. I cannot just
all your team members.
This is procurement.
Okay.
The next team will be packaging.
Okay.
Procurement and then.
This year we did not say any method.
We can show I can apply Kaizen.
So this is our 2026 ability.
Right. So let's get started. So we will start with minus 2 judges for now for this presentation. So I think they are in the middle of discussion of very important things. So we will consolidate. And I'm sure that they have seen the presentation earlier, so I think they can able to put some scores, hopefully. Right? Okay. So without any further delay, so let's put our hands together for Ms. Navapon and Ms. Sudamas from SBFAP procurement team with the title Supply Continuity of EOC as a subject.
Good afternoon, everybody. Before going to our story, let's refreshment with our products, which we have very long session of Kaizen today. Oh, normally it's simple to open, but today I'm very excited. We are from Century Western and Food Thailand. I'm Navapon from the procurement, and my partner is Suthama from China. Today, we are going to tell about the story of supply continuity of SBFAP chicken. Let's start with us. First, our company, our factory is located in Pin Thailand, in Chonburi province. We have many products like EOC, SBFAP chicken, burger, specific solution, tablet, and also instant and hamburger. Let's start with our MTP in 2022 to increase net sales value and profitability. So we see the opportunity to increase the penetration of SBFAP chicken. Let me call it EOC. Let me explain why it has to be EOC. EOC is the highest sale and profit contributor. We have the highest sale contributor with 54% and also highest profit contributor with 66%. So we're very confident to ensure supply continuity of our base seller will be help our company to achieve the target. And how to support the EOC penetration? We have to ensure the sustained supply continuity and also ensure activity conform with Suntory monocyclic value mission, safe, reliable, and high quality material and products. To ensure supply continuity of EOC, we evaluate the risk mitigation for each material in EOC. According to risk evaluation metrics, we evaluate in more criteria in the category risk, supplier risk, and business impact. And then we found that our EOC have our poultry is the key material of EOC, and it has a chance to high impact on business level due to the overall risk exposure is high and risk mitigation needs to be revisited. So we confident to that we select the theme of this project is supply continuity of poultry to support SBFAP chicken penetration strategy.
Let me walk you through our current supply situation in 2022. For the list of top poultry manufacturers in Thailand, there are 9 top manufacturers. We qualify the top 2. There are CPF and Betago, which are largest slaughterhouse. For the list, haven't been approved yet. Poultry supply lead time is 4 45 days. Raising chicken at the farm take up to 42 days. In addition, our orders are based on the quota allocation that we agreed with the supplier at the beginning of the year. So it's not possible to change the order after that. In 2019 and 2020, supplier capacity enough for our usage, but in 2021, supplier capacity decreased by 60% due to COVID-19 situation. In the past, WO were able to fulfill 100%, but in 2021, they were unable to fulfill our order. It affected to our protein stock reduced to the zero, and production line had to stop in that period. So we set the target one to achieve 100% usage fulfillment in 2023. This target related to supply continuity to ensure we have enough supply to serve even during crisis situation.
And moreover, for target 2, we need to bring down the risk exposure score to from 15 score in supply to the medium risk as 5 to 9 score within 2023.
For the measurement of target 1, percent fulfillment calculated by number of actual order shipment divided by number of planned order shipment.
And for measurement of target 2, based on price evaluation score, is calculated from weighted probability score and weighted impact score. So how to achieve the target? What will be the our considering? We use the YY analysis to analyze our challenge of poultry short supply. We look into 4 areas, which are man, machine, material, and method. Let's go to the first area, is man. There are worker shortage at slaughter farm and at slaughterhouse and farm during the COVID-19 situation due to government policy of social distancing. So in this area, it is restricted for further action. And for another area, that machine, there are various machines in slaughterhouse. As we all know, to implement or invest the new machine is taking more time and lot of investment cost. So in this area, it depends on supplier. And for the area of method, we use a specific poultry usage and part. It will be impact to our quality control, efficacy like climate in EOC, and also production yield. So we decide to no touch in this area also due to it will be impact to our consumer benefit. So for the another area of material, and only 2 approved suppliers and their capacity decreased by 60% due to COVID-19 situation. We are ensure to do the alternative chicken supplier, and for another challenge is very challenge for us, but it's a good point to revisit our specification. So our management and our team agree to quickly qualify and implement the project, qualify alternative supplier, qualify alternative chicken breed, and qualify alternative chicken part. For the project timeline, after we analyze countermeasures, there are 5 projects which start from 2022 and will be achieved within 2023. Let's go to the first project from the countermeasure for project to increase supply capacity. There are more suppliers for whole chicken, more suppliers for chicken breast, and more chicken breed is lost. In order to get another supplier, it is not just qualification to supplier, but also the new chicken breed that we have never been used to qualify another breed, which we can see from Gemba as supplier farm, and get more idea to increase supplier capacity. And the qualification process that shown in the slide is according to Suntory monosplit value, creating safe, reliable, and high quality products. Qualify new supplier is not simple because we have to involve a function with over 60 parameters. It is just not physical, appearance, or sensory, but we have to comply with efficacy also. For the first two criteria is centric, efficacy, active marker, and sensory must be within our control and verified by scientific research and product development. And for the regulation, also must comply as per guideline from IET. For the quality, protect the customer, the quality control and quality system will be validated by quality team. And I cannot make the production upset. You have to meet our target also. And for planner, flexibility of call-in plan, also the key point that we have to consider. And last but not least, price must be competitive, and supply financial have to part of the finance check. And then we can approve the new, and then we can approve the new supplier is food to support our demand and can extend our spec to use another breed that have in the market. For another group of projects to increase supply capacity and reduce cost impact. For the first one, alternative spec of whole chicken without tails. At that time, it's very tough situation to us. Supplier cannot lower the price due to the factor that already mentioned above. What we did is we explore the price of each chicken part, like a Gemba anatomy of chicken. So we check which supplier which is the valuable part for them. Then it is a win-win solution for both sides. We found that supplier has highly demand of chicken tail. Tail is the highest percent fat for chicken part, and fat is also the thing that we have to be eliminated from our production line. So we agree to use the spec whole chicken without tail, and supplier can sell the chicken tail at the higher price, so they can lower whole chicken price for us because we can accept the whole chicken without tail. And especially in Japan. Another spec is alternative spec of chicken breast. Again, this project is Gemba as supplier line. At that time, chicken breast supply is limited and the price went up higher. So what we gonna do, get more supply to cover our demand. Team had a chance to go to visit supplier factory, so we take this opportunity to get back the chicken breast line. Then we found less beautiful chicken breast like this. Some parts was cut, not very nice, and the shape not complete, not beautiful. So we quickly qualify these alternative steps, went through all the qualification steps as I mentioned above. For the result in efficacy and application step, this is the most that we have concern. Team evaluate that sensory, physical properties, amino acid profile, liquid chromatography mass spectrometer, and active marker are compliant in our control. Let's see the result for our project that we implement. First one, we can increase supplier from 2 to 3 supplies. And the capacity increase around 3,000 tons per year, which equal to 33% of our usage. And for the cost impact, the new supplier can offer lower price that can reduce the cost impact by 35%. And our supplier also very happy that they can value add at the lower spec part like interest. Our relationship with supplier is even more strengthened.
Okay, if we implement all the countermeasure, the result of the target one, we can achieve 100% state fulfillment in 2023.
And for the target 2, we can bring down the risk of poultry to medium risk level, like 7.6 score.
For the standardization, we added alternative space and with supplier in the system. Moreover, we found the best practice something like at first, continually poultry category management. Next one is continually supply risk evaluation. Business review with the supplier, and the last one, long-term strategy of poultry.
For the tangible result, we got the tangible result for supply continuity and also reduce cost impact by 35%, is equal to 28.1 million baht. For the risk, for our project, we have 5 projects and can get contribute from them. For the risk mitigation is not only alternative suppliers, but also other measures to do, for example, to challenge the spec. And for the idea initiation is not only from internal, but also from external. For example, for discussion with supplier, impact